All right, let's do this example here. Before we do, one thing I did want to mention when I was writing the solution sets in set builder notation, realize that if it includes negative infinity or positive infinity, we don't normally put that in our less than or equal to in our intervals. For example, in the last example, I think it was greater than or equal to 3, and I wrote less than or equal to positive infinity. Normally we wouldn't write that second part. We would just say it's greater than or equal to 3. That was my bad. I wasn't thinking about that because that would be unnecessary. In fact, it might be confusing to say less than or equal to positive infinity or less than positive infinity. So we would, if we're saying it's going up to infinity, we would just say greater than or equal to 3. And so just remember that. I'm going to do the same thing here, so when I get to that, I'll explain. And that was for just when you're writing set builder notation. Okay, so let's do this one here. We're going to solve this for less than, but then we're going to change it up a little bit. Okay, so let's go through part A. And now in this case here, let's see what this factors into. So the first thing we're going to set this equal to, it's already in the form that we want. So all we're going to do is make it equal, right? So if we factor this, there's nothing to factor out. There's no greatest common factor. So if we use the AC method, so that's 36. So we want 2 factors of 36 that will add to a negative 12. Now the fact that our AC is positive means that the signs of the factors have to be both the same. And the fact that we have a negative middle term tells us that they both have to be negative. So we want 2 negative factors of 36 that will give us negative 12. Okay? And in this case here, what are 2 factors that will do it? Well, 36, 4 times 9, 4 and 9 will do it, but that won't give us 12. What else will give us 36? 3 times 12. But that won't give us negative 12. So negative 3 and negative 12 won't do it. We need 2, so they have to add to negative 12. What is it? It's not popping out of me. Maybe I'm getting fixated here. So 36. So 36, 2 times 18, 2 and 18. Three and 12, 4 and 9, let's try it, hold on, 36, so we got 1 and 36, 2 and 18, 3 and 12, 4 and 9, Oh, hold on, let's see, 6. Oh, here we go, 6 and 6. Yeah, 6 and 6 will work. So -6 and -6. So let's do that. So that'll give us 4x squared minus 6x minus 6x plus 9 is equal to 0. And then of course we factor by grouping. That if we factor out what's the greatest common factor here, that's going to be a 2x. So that'll give us 2x minus 3. And here I'm going to factor out a -3. Yeah, let's factor out a -3. So that'll give us 2x minus 3 is equal to 0. And again, we've got a common factor. So if we factor out the 2x minus 3, that'll leave us the other factor of 2x minus 3, which is a perfect square. And so that means we have a solution, x equals 3/2. And notice that this 0 has a multiplicity of 2. But anyway, this is our boundary point. So that means our interval is going to go from -infinity to, what was it again? Three halves, right? Yeah. And then 3/2 to positive infinity. So now, in this case here, since it's less than, we're not going to include the 3/2 in our solution set, because that's where it's equal to 0. We want everything where it's less than 0. So now this is where we're going to use our test points to find out the sign. So here I'm going to use 2. 2 is in this interval. And again, if I use the factored form, which was 2x minus 3 squared less than 0 or equal to 0. Because again, we're just testing for the sign. Now the thing is, since this is squared, it doesn't matter what x is. It's always going to be positive. So that means it's going to be positive here, and it's going to be positive here. Okay. Just want to double check this here, just make sure I'm looking at this right. What if we have less than 0 here? Well, since it's positive on this interval, and it's positive on this interval, and it's 0 at 3/2, well, that means that in this case there is no solution. So the solution set for this inequality would be the empty set. And we would just write it like that. The set that has nothing in it. Or another way of writing it is like that. Just don't put these together. So you either write it this way or you write it this way, but typically we probably want you to write it this way. This is just the set builder notation where we have nothing inside. So that's the empty set. That means there is no solution. Okay? This is another way of writing the same thing. It just means it's the empty set. Okay? Now, what if I put an equal sign there? So that's part B. What happens now? What happens to the solution set? If the solution set is less than or equal to 0, well, then the only thing that would fall into the solution set would be 3/2. That's it. Because it's the only part that's equal to 0. Everywhere else it's positive. Okay? Now, what if it was greater than? If it's greater than, then our solution set would be what? It would be -infinity to 3/2 union 3/2 to positive infinity. Okay? Or, basically you're saying everywhere except at 3/2. Did I say 2/3? I meant 3/2. So if I did it in set builder notation, it would be like this. The set of all x such that x is not equal to 3/2. Right? I could write it that way. Or I could write it this way. The set of all x such that what? X is, not greater than. X is less than, not equal to, less than 3/2, or x is greater than 3/2. So notice here I didn't include negative or positive infinity because it's included in the inequality when I say less than 3/2 or when I say greater than 3/2. Okay, so I could write it this way, or I could just say x is not equal to 3/2. Either way is fine. Now, what if I had the equal sign here? Now, in this case here, then it's all real numbers. Right? It includes everything. So I would just say, in interval notation, it'd just be negative infinity to positive infinity. In set builder notation, I would say the set of all x such that x is an element of the reals. right? That's all real numbers. Okay? Or I could say such that I guess that's the best way of doing it. Yeah, I'll just leave it at that. All right. There we go. Have a great day.